This video covers section 10.1, solving quadratic equations by completing the square. Objective 1, solve quadratic equations using the square root property. We've solved quadratic equations before, but we were limited to only ones that factored. And when we would factor them, we would set those factors equal to 0 and get x is equal to 7. Or x plus 2 equals 0 says that x is equal to negative 2. So if it factors, we can solve the quadratic equation. If it doesn't factor, we need a new method. And to set that method up, we solve by taking square roots. Given the quadratic equation x squared is equal to 16, we solve this by subtracting 16 from both sides and then factoring x squared minus 16, difference of squares, as x minus 4 and x plus 4, giving us the two solutions, x equals 4 or x equals negative 4. So we saw that anytime we had the difference of two squares, it would factor as a plus and a minus of those square roots, giving us x is equal to 10 or negative 10. So we can expect then, if we see something like x squared is equal to 81, we should expect 9 or negative 9. And so this is a more efficient way to look at these. We're thinking of in x squared equals 16, we're thinking of the two numbers whose square is 16. They are 4 and negative 4. When we think of the equation x squared is equal to 81, we're thinking of the two numbers that we can square and get 81. So those are just the square roots of 81, plus or minus. So if we have x squared equals a number, then x is equal to the square root of that number, or x is equal to the opposite of the square root of that number. So we say, take the square root of both sides, making sure to use a plus or minus. Writing 9 or negative 9 is the same thing as writing x equals plus or minus 9. The square root property is useful for solving equations of the form some unknown squared equals a real number. To solve this equation, take the square root of both sides, but don't forget the plus or minus to obtain the positive and the negative square root. So if we can write our equations in the form x squared equals a number, in this case add 24 to both sides, then we take the square root of both sides, remembering to use a plus or a minus. That says that x is equal to plus or minus 24 is 4 times 6, so the square root of 4 is 2, leaving a 6 underneath. Seven x squared equals 112. Divide both sides by 7. 7 goes into 11 once with the remainder 4. 7 goes into 42 6 times. There's x squared equals 16. We take the square root of both sides, making sure to use a plus or minus, and that gives us x is equal to plus or minus 4. Letter C, we divide both sides by 3, and that gives us x squared is equal to negative 9. Now we know there is no real number that you can square and get a negative 9, but we have seen complex numbers already. So when we take the square root of both sides, we have the square root of negative 9. And don't forget the plus or minus. So the square root of negative 9 is 3i. We have a positive 3i and a negative 3i. This leads us to 3 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. We take the square root of both sides of the equation, remembering to use a plus or minus. Square root of x squared is x, and that equals plus or minus 48 is 16 times 3, so we have 4 square root of 3. Letter B. We add 75 to both sides, and then divide by 3. This gives us x squared is equal to 25. We take the square root of both sides. Don't forget about the plus or minus. Gives us x is equal to plus or minus 5. Letter C, we subtract 75 from both sides. 3x squared is negative 75. Dividing both sides by 3 gives me x squared is equal to negative 25. Taking the square root of both sides, using a plus or minus, we get x is equal to plus or minus the square root of negative 25 is 5i. Example 2. Now the square is on a binomial. The square root property works anytime the square is on some kind of expression with an x in it. We take the square root of the left side. We take the square root of the right side, remembering a plus or minus. Square root of x minus 2 squared is x minus 2. Square root of 16 is 4. So that's x minus 2 equals plus or minus 4. Now, when you add 2 to both sides, you can't add it to this 4 and write 6. It's 2 plus 4 and 2 minus 4. So the two answers are 2 plus 4 is 6. 2 minus 4 is negative 2. So the solutions to this are x equals 6, or x is equal to negative 2. Letter B, we isolate the x minus 2 squared by subtracting 12 from both sides. And now we take the square root. The square root of a square undoes it and gives us x minus 2. And we have plus or minus root negative 12. The negative comes out as an I. The 4 underneath comes out as a 2. And the root 3. 12 is 4 times 3. So we take a 2 out and leave the 3 under. Now when we add 2 to both sides, we have 2 plus or minus 2 root 3i, and we leave it like that because they're not like terms. These are the complex number solutions. And here are 2 practice problems for you to try. I encourage you to press pause on your video and work these out, and come back when you're ready to see the solution. Now that you've had a chance to work these out, I'll work these out with you. We take the square root of both sides to undo the square, remembering to use a plus or minus. So on the left-hand side, we have y plus 3. On the right side, we have plus or minus 10. We subtract 3 from both sides and get y is equal to negative 3 plus 10, or negative 3 minus 10. One of the solutions is negative 3 plus 10. The other one is negative 3 minus 10. So we get y is equal to 7 or negative 13. Letter B, we subtract 20 from both sides, and we get negative 16. That's x minus 5 in parentheses squared. We take the square root of both sides, remembering the plus or minus. This gives us x minus 5 equals plus or minus square root of negative 16 is 4i. To solve for x, we add 5 to both sides, and we get x is equal to 5 plus or minus 4i. That's your complex solution. And this concludes the video for section 10.1, solving quadratic equations by completing the square. Objective 1, solve quadratic equations using the square root property.